So welcome back to the adventure, guys. Today we are going to be finishing up our electrical bay install and hopefully get some stuff running permanently on our batteries. We've got to figure out a way to mount this. This is our Victron Lynx distributor. We got to mount this in that electrical bay and then start wiring things up. This is, one step closer to a permanent installation. Can finally get rid of this temporary power supply. Okay, I think I'm liking this here. Maybe I'll put it here. So this thing I'm installing right here on the negative terminal, this is called a shunt. This is what's going to measure all of the current leaving the battery or going into the battery and tell us how much power we're using at any given time. Oh, why are you so close? I want to give this some space, but I still need to be able to connect to it. Let's do it right there. So I'm making the wire for the connection to our inverter. So I've got this really big 2-aught cable. I'm going to crimp this connector on the end for a nice big hand hydraulic crimper. Well, that looks nice. Sweet. I'll leave a link to that crimper in the description. Alright, so that's easy. I could just cut this right at the A. This is my idea. We'll see if it works or not.
Oh geez.
Yeah. I don't know why I didn't think it wouldn't work.
Yeah.
So this is what happens if you have a nick in your heat shrink and you have to get this while it's still warm. Otherwise it's going to be a pain. Especially a really nice heat shrink with the glue in it. Massive pain to get off. Unless you get it while it's still warm. Let's try this again. So all of our cables are hooked up, and then the next is the communication lines. So there's something that gets plugged into one of these, and then there's something that gets plugged into the shunt back there. That way it can communicate with the hub that we put in next to our stove. There we go. So we're pretty much ready to put the batteries in. I just have to put the last little bits of the power cable on. And it's gonna have to be temporary and a little janky, but I'm still waiting on a couple more parts, so there's only a little bit of temporary left in this system. I'll show you what I'm about to do here real quick. So this is gonna look very bad, and it's probably not that good, but it's not as bad as it looks. And that's because we don't have a main fuse right now. It's still on order. And yeah, we don't have a main fuse right now. It's still on order. And so I'm just bolting one wire directly to the other wire. I literally just bolted 2 wires together. I'm going to insulate it with some heat shrink. I'm not going to shrink it, I'm just going to stick it on there. And the reason that, yes, it looks very bad, but it's not as bad as what it looks like, is because this goes to the bus bar, and then everything coming from the bus bar is all fused. And every single one of these fuses on here is weaker than the wire that's supplying the main bus bar. So if anything's gonna fail, it'll be right here. If it fails before this, then we have an issue. But it's less than 2 feet before the battery. So we just need to make sure it's not going to get cut by anything, and this is not going to touch anything. There's no possible way. I might end up just wrapping this with tape just to make sure the heat shrink doesn't move. But yeah, everything should be fine, and we should be ready to test with our batteries. This is a tight space, and I've been in here for a long time. Let's vacuum this up and let's test it. Okay. There we go. So that is on. That is not on. Why is the shunt not on? But this turns on. Does something. So we're gonna go revisit the shunt and see if we can get that fixed. Let me hook this up, and then that should be the last piece that we need to get the
Out.
oh. Okay. So now let's go see if the shunt works. And look at that. The shunt works. Let's see. -3 amps going out, huh? 99% capacity. 20 hours of the current power usage. Let's see if we go -2.14 amps going out. What is going out? Oh. How many amps now?
0.47.
Sweet. So now what about this?
Just open the fan.
Just open the fan. Almost 1 amp.
Just about an amp, yeah.
Full blast.
Not too bad.
No, not bad at all.
Not too bad at all. That's pretty good.
Oh, wait. What was supposed to turn on? There we go. Sweet. So we've got about a ½ amp of parasitic draw on everything. With everything on. Actually, except for the inverter. So let's turn the inverter on. Now there's no power connected to it. This is simply the inverter in standby mode. It's drawing 4 amps. Let's put it in power saver mode. Oh, now I think it'll use... No, I think that turns it on when it's connected to power. Almost no load on it. Sweet. Now, I'm going to plug in the battery charger. So we should see this change to a positive something.
Hope so. Awesome. Positive 16.4. And there it is. There's the charger.
So we should see seeing about 20 amps in.
About 16?
16, so that's about 18.
Yeah.
My meter might not be calibrated, but
I mean, well, it has draw.
yeah.
So,
It has draw of how much? 4.
4. So that's
Right.
20.
Oh, that's 20.
Yeah.
Alright. Yeah, so that's 20 amps going in. So we're charging the batteries at 16 amps.
Sweet.
Nice. Now, for the final test, I'm going to turn on the AC on the inverter.
You gonna unplug it from the truck?
Yep, I'm going to unplug the truck.
You gonna let it charge for a little longer?
Nah.
Okay. Alright, so everything just powered on. Kimi has unplugged the truck. We're now running just on inverter. 12 volts working, the 120 is working. So for the test, and it's at negative 6.3-ish.
How much is that using?
Let's
Output
see.
load 3%. %? Okay. Go ahead and turn on the... 97%?
99.7.
Oh, yeah. Okay. Yeah, you're right.
So the AC is running. And what are we looking at, Kimi? Battery's at 98.9 now. So it's going down pretty quickly.
AC hasn't actually kicked on yet.
Yeah.
Just a
Yes, it
fan.
has.
Is it?
I feel it.
You
It's
feel
cold.
cold?
Yes.
Wow, that thing is quiet.
That thing is so quiet. Yeah, this is cold. It's cold already and whisper quiet. How are you looking?
It's dropping very quickly.
Yeah.
But it's running.
Also, our batteries are, well, they're old car batteries that we picked up for a deal, $40 each. And these batteries aren't even like deep cycle batteries. They're just they're just starting batteries that we got from the battery dealer from customers who were like, I'm upgrading my battery. But these batteries still worked with, or they still outputted their cold cranking amps needed for starting a car. So they passed, but they were just not great. Yeah, we got them for $40 each. So it can't beat that. It's good for overnighters. It's not good for the batteries. But we don't really care because they're not our permanent setup. But right now it would be way too expensive to get batteries up here. Yeah, they wanted something ridiculous for shipping, as you could imagine. All right, so that was a successful test. It's cold in here, like really cold. I'm gonna go stand in the sun in a sunbeam for a while and warm up a little bit. The door's still open. We don't even need to turn the air conditioner on for more than like maybe 5 minutes at a time, I'm guessing.
Disconnect that and get away from the noise. So that is called a converter. A battery converter converts AC to DC. A battery inverter converts DC to AC. So essentially that's a charger. That takes the regular 120 volts coming out the wall and converts it to something that can run, or that can charge the batteries. And yeah, it just charges it. It's not much different than a regular car charger. So we don't have our battery transfer switch yet. So when we want to switch from the inverter to, or from shore power to the inverter, we have to plug it in right here. We have to plug the truck in right here. And this looks really janky, and it is. It's temporary. It's very temporary. So don't worry, we're not going to keep it like this. But right now we just have to take this big black cord that we have plugged into the wall and plug it in right here. And then we're running the whole truck on the inverter. Because we don't have our battery disconnect yet, or I'm sorry, not battery disconnect. Because we don't have our transfer switch yet, we have to turn off the converter. Otherwise it will just pull power out this outlet right into the core, which then goes into this, which then goes into the converter to then charge the batteries, which are actually running this to then power the converter to then charge the batteries. And it's just like, it's an endless loop, and you're just sitting there cooking all your energy away in losses. Because right, nothing's 100% efficient. So even if it's 80% efficient, how long is that going to take to just drain all your batteries? Inverter's 80%, this is 80%. Yeah, you're just sitting there chewing up 40% of your energy forever until everything's dead. But that's temporary. That's just while we wait for our battery transfer, or our automatic transfer switch to come in. Once that comes in, all of this will be automated. Then we'll just, when we plug in, it'll click over and run a different circuit, and when we unplug, it'll click back over and run a different circuit. Put this cover on, and then we should be done for the day. Okay.
All done?
All done.
Nice. Alright y'all, that's gonna be it for today's video. I really hope you enjoyed it. If you have any questions about the electrical system, drop them in the comments and we'll be sure to get back to you right away. If you like this video, push the like button and subscribe, and we will see you guys next time. Bye bye.